All right, so this is part two. We'll start looking at multiplying. So we should be familiar with the distributive property somewhat, but this will go a little bit further in depth. But here's the rule. If you have A times parentheses B plus C, you have to multiply everything in that parentheses by that value on the outside. And so that's what we're going to see here. So this first one, pretty basic. You've probably done some already similar to this in our first unit. So we're going to go ahead and distribute the 3. So 3 times 7 times x, because remember that's 7 times x. So you can do the 3 times 7, which is 21, and then times x, we'll just leave it right there, times x, right? And then plus 3 times 5 is 15. That's it. There you go. Now what's going to be different moving forward is now we might be distributing a variable along with it, okay? And so I'm going to go ahead and do this, and I'm going to really show every little detail, but once you get comfortable with this, you really can kind of skip some of the tedious steps if you'd like. So I'm going to go ahead and put, let's see, 2b times 3b minus, and then let's see, 2b times 8. And so I tried to color code this. So the 2b right here is in purple, and it's going to get multiplied by both of these. So what you have to realize is in both places here, all this stuff is just being multiplied together. So you really have 2 times b times 3 times b. And as I've mentioned before, multiplication is commutative, which means we can kind of move things around if we'd like. So I'm going to go ahead and put the 2 times 3 and then the b times b right there, minus 2 times 8 times b. And so let's see, 2 times 3 is 6, and then b times b, you add the exponents, so that's going to become b squared, and then minus 2 times 8, which is 16, and then you have that times b that we just tack on right there, and that's the answer. Now, as I was saying, as you get more comfortable, I mean, you can go directly to the answer. You don't have to show all that work, but I wanted to show it at least for the first one. I'll probably show quite a bit of work on my next one. But see, it's just 2 times 3 is 6. B times b is b squared. 2 times the minus 8 is minus 16, and then the b is getting multiplied also, which you just tack it on at the end right there. So if you're comfortable with that, that's fine. Not a big deal. Okay, so on 16, what I want you to notice is you're multiplying by a negative 6x squared. So that negative is going to cause a sign change for all of these. So this will become positive, positive, or positive plus, and then a minus here, okay? And then they're all getting multiplied by x squared. And so remember, when you multiply, you add the exponent. And so that's all that's going to happen here is you'll add with your exponents right here. Now, if you can do it in one step, great. I'm going to go ahead and break this up into a few steps, though. So let's see, negative 6x squared times negative 9x to the third power minus negative 6x squared times 4x squared. And let's see, I'm running out of room a little bit. Okay, I made a little bit more room. So then let's see, then we're going to have a plus. Let's see, negative 6x squared times 5. And sometimes showing more work actually might even confuse you. Sometimes it's better just to, just do each part in your head. But anyways, I already got this going, so we'll finish this. So let's see, I've got a negative 6 times a negative 9. So a negative times a negative is going to be 54. And then you add the exponents when you multiply the x's together. So that's going to be x to the 5th power. So like I said, you probably could have done that without having to rewrite it, but I'll leave that up to you. So then we're going to have minus, and then when you multiply a negative times a positive, that will be negative 24. Add the exponent, so that's going to be x to the 4th power. And then we have plus negative 6 times 5 is negative 30, and then you still have the times x squared, so we don't want to forget about that. We tack that on the end. Now I have to fix my signs. So I have minus a negative, and I have plus a negative. So whenever you have a double negative right here, that will become addition. So 54x to the power of 5 plus 24x to the 4th. And then plus the negative, we can simplify that by putting it just as minus 30x squared. So it's considered to be more simplified. The less ink I have, the more simplified it is. So if I can change having those two signs into a single sign of just a minus, that's considered to be more simplified. Now, like I said, it might, writing this all down might have actually made it even more confusing. It might have just been easier just to kind of do each part in your head. So, negative 6 times negative 9, positive 54. And then deal with the variables. Negative 6 times a minus 4, double negative, it becomes addition, right? And then negative 6 times that plus 5, that would become a minus 30. And then, obviously with the variables. So anyway, sometimes, it just kind of depends. Some students, they're fine with the shortcuts. Other times they really want to dive in and see the finer details. Okay, but as I move on, I'll probably be taking the shortcut a little bit more often. All right, so here now we're going to be multiplying two binomials together. Okay, on the previous page, we were just multiplying a single term, a monomial, by a polynomial. So this is probably something you've done in the past. Maybe it's been a while, but we typically like to use the acronym FOIL. So FOIL, FOIL. And this is just a little process to kind of help you remember how to multiply these together. There's other little tricks that you might see if you look on the internet, and they're all, they're all pretty good. But what you want to do here basically is see this x is going to get multiplied by both of these. And so see the first two terms get multiplied together, and then the outer two terms are getting multiplied together. That's where the f and the o come from. So you're going to multiply x by both terms in the second polynomial. So x times x is x squared. X times a plus 3, that would be a positive 3x. Then now you multiply the second term in the first polynomial by the two terms in the other polynomial. And so see, this is referred to as the inner, and then the outer, because you're, the last. So you have the inner and then the last two terms of each polynomial are getting multiplied together. Typically, I think just writing these arcs will help you memorize how to do this. So the first term goes to both of these, and then the second term goes to both of these. And anyways, I think that'll probably help you out. So let's see, plus 7x, because 7 times x, and then 7 times 3, let's see, that'll be 21. And then not all the time, but most of the time, these are going to end up being like terms in the middle. So we can go ahead and combine those. So we're going to have x squared plus 10x plus 21, and that is our answer right there. So that's kind of interesting. It looks very different from where we started, right? But those are equivalent to each other, and if you don't believe me, you can plug in any number you want for x. You could let x equal 1, 2, 3, negative 10, whatever you want to let x equal, and plug it into the expression up here, and you'll get the same result down here if you were to plug that same number in. So just realize we're not even solving anything right now. We're just manipulating the expression into a different form. Okay? And just kind of give you a heads up, really the main goal is going to be to go backwards. In some lessons later on, we're actually going to take this and we're going to actually try to write it as two binomials. So right now we're this is the easy way. The easy way is just foiling it, but later on we're going to undo the FOIL. So you can worry about that later, but just kind of keep that in mind. Okay, so for our next one here, we're going to multiply the x by both of these. So we're going to get an x squared and a plus 3x. And then we multiply. Now be careful, you're multiplying the minus 5, so you got to take the sign with it. So negative 5 times x is negative 5x or minus 5x. And then, let me fix that. And then now you're going to multiply the minus 5 by the positive 3, so that'll be a minus 15. And then in the middle, we got those like terms again. Now be careful, one's positive, one's negative. So take the difference, keep the sign of the larger, so minus 2x, and then we got a minus 15 right here. And there we are. Okay, another one here. So let's see, we'll start by multiplying the 2x by both of these. So we're going to get 10x squared, then plus 6x. Then we'll multiply the minus 3 by both of these. So let's see, that'll be minus 15x, and then minus 9. And then once again, we'll combine those terms in the middle. They have different signs. So take the difference, keep the sign, keep the sign of the larger. It should be a negative, or minus 9x, and then we have a minus 9 on the back end right there. Alrighty then. Okay, I have a couple more. To be honest, it's more of the same, but we kind of consider these special cases because they have a pattern to them, okay? And so the pattern of the first one we're going to look at is the product of conjugates. And so conjugates, that's just a fancy word for that the two binomials match, except one's plus, one's minus. That's the difference. There's some different variations on that, but this is typically what ours are going to look like. So you'd have one with plus, one with minus. And so what happens is, whatever that first term is, you would get a squared minus, and then whatever that second term of each of those binomials are. So let's go ahead and look at our first one. So we've got x plus 3, x minus 3. So if you were going to take the shortcut, these would be your a value right here, and this would be your b value right here. So it would just become x squared minus 3 squared, which then would become x squared minus 9. And that is the answer. But I'm going to go ahead and FOIL it so you can see the process here, because conjugates will be something that we're going to use more than once throughout the semester. It'll come up in different units where it's a useful tool to help us simplify problems to solve them. So if we're going to FOIL it, let's see, x times x is x squared, then x times the minus 3 is minus 3x. Then 3 times x is plus 3x, and then 3 times a minus 3 would be a minus 9, right? Positive and a negative. And then what you'll notice is in the middle, those cancel out. You have minus 3x, you have plus 3x. Those are opposites. They nullify each other. So it just gets completely canceled out, and you're left with x squared minus 9. Okay, so if you're comfortable with this shortcut, great. If not, it doesn't really make a difference. When you FOIL it, it's going to cancel out the middle terms anyways. Okay, so if you look at 33, I'll go ahead and do the shortcut, and then we can FOIL it again. So the first term would be 3x squared. So you got to square the whole thing, not just the x or the 3. You've squared the whole. This is your a, this is your b. So you got to square that first term, okay? And then minus, and then you square the second term, which is a 2. So when you square this, if you remember from our previous lesson, you square both of them, so it'd be 9x squared minus 4. And that's our answer, and you'll see that in just a second when we FOIL it. So I'll start by multiplying both of those by 3x. So let's see, we get 9x squared minus 6x. And we're going to multiply that plus 2 by both of these. So we'll get plus 6x minus 4. And then in the middle, once again, those just cancel out. And that's what's special about these conjugates. And that's actually what we like about them. And like I said, it'll be something that we'll see later on in some of our other units. So the word conjugate will come up again later. Okay, the next type we're going to look at is perfect square trinomials. And once again, these will come up too. Probably not quite as often as the difference of two squares or the conjugates, but it's still, this is important. So the most common mistake students will make, and this is incorrect, is they'll say, oh, x squared minus 3 squared. Okay, that's incorrect. Okay, that's incorrect. Now, if this was multiplication, sure, then yeah, you square both of them. But whenever there's addition or subtraction, you can't do that. If there's multiplication or division, fine. Addition or subtraction, that's not quite how it works. Now, there is a pattern up here, and we'll talk about this later because this one's a little bit, it's not quite as straightforward as the one up above. It's a little bit more abstract. So, anyways, the way we're going to do this is, think about this. If I asked you, what is 5 to the second power? You're going to say 25. And that's because 5 times 5 is 25, right? Well, if I have x minus 3 squared, that's no different. It should be x minus 3 times x minus 3, right? Just like how 5 squared is 5 times 5. So now that I have two binomials, I'll go ahead and FOIL it together. So I multiply the x by the two terms in the second one. So we get x squared minus 3x. Then I multiply the second term by both of these, and I'll get a minus 3x again, right? And then I'll get a plus 9, because a negative times a negative makes that last one a plus 9. And then in the middle, those are the same. So let's see, negative minus 3x minus 3x. So when you combine that together, that's a minus 6x, and then plus 9. Now, the pattern for this one up here is whatever that first term is, you'll square it, and that's the first term, okay? And so you can see right there, so x squared, that's my first term. Then in the middle, you see I have a plus minus sign. Basically, that's saying if it's a plus in the middle, it'll be a plus here. If it's a minus, then it will be a minus. And then the last one will always be plus. You don't have to worry about that. But here in the middle, it kind of depends. Whatever you have over here will match over here, okay? And so then, let's see, we have 2 times a times b. And the a and the b are the values inside here. So you're going to have 2 times x times 3. 2 times x, 2x times 3 is 6x. And then I have a minus here, so I'm going to have a minus here. So there's my minus 6x. And then the last one's going to be b squared. It's always plus. And so my b was a 3, so plus 3 squared, which 3 to the second power, 3 times 3 is 9. And there we go. So if you like the shortcut, great. If not, go ahead, break it apart and FOIL it. It's not really a big deal. But if you do take the shortcut, if you do about 5 or 6 of these in a row, you'll get the pattern down, and it's pretty simple. So square the first term. Okay, multiply this together and double it. So x times 3, 3x, double it, so it's 6, and then match the sign right there, minus 6x, and then square the 3, which would become a 9. Okay, so on this next one, if you're going to take the shortcut, I'll do the shortcut real quick, and then we can FOIL it. So square the first term, that would be a 4x squared. So you've got to square the coefficient and the variable. So 4x squared. Now multiply this together. That would become a 6x. Then double it, right? That's where the 2 comes from. So double it. So that'd be 12x. Now I have a plus here. So I'm going to have a plus here. Let me see. There we go. Plus 12x. And then square the last one, which should become plus 9. And that's the answer right there. But I'll go ahead and show you by FOILing it also. So first things first, let's see. So we'll rewrite this like so. And then let's see, we're going to multiply the 2x by both of these. So we're going to get 4x squared. And then 2x times 3 is plus 6x. And then when I multiply the plus 3 by both of these, I'll get another plus 6x, 3 times 2x. And then 3 times 3 is 9. And then in the middle, I have like terms. They're both 6x. Add them together. That will give me a 12x. And then I have that plus 9 right there. And there we go. Okay, so students usually it's pretty mixed. Some like the shortcut and they have no problem with it. Others, they always break it apart and FOIL it. You just have to figure out whatever's right for you. Okay, so on our last part, you're multiplying a binomial by a trinomial. It's actually very similar to what we just got done doing. So what I'm going to do is I'm going to multiply the 2x by all 3 of these, and then afterwards I'm going to multiply the minus 3 by all 3 of these, okay? So basically the first term gets multiplied by all of them in the second one, and then the next term gets multiplied by all the same ones, okay? Now I'm going to write this a little different just because basically I'm going to organize it a little bit as I multiply it out. So let's see, 2x times x squared would be 2x to the third. 2x times a minus 3x will be a minus 6x squared, okay? And then 2x times that plus 5 will be plus 10x, okay? So all I did was I multiplied the 2x by all these terms right here. So they all got multiplied by 2, and then the x increased their exponent by 1. So from a 2 to a 3, and so on. Now I'm going to multiply the second term. Negative 3 times x squared. Now I could write it over here to the right, but if I keep writing, I'm going to end up getting into the space of my next problem. So, well, a lot of people like to do to kind of save some space and kind of organize this, what I'm going to do is, so I'm getting a negative 3x squared or minus 3x squared. I'm going to put it right below my other x squared. So I'm lining up my like terms vertically, okay? And what it does is it saves you a little bit of space so you're not writing all the way across your page. And plus you're organizing it at the same time. Okay, then let's see, negative 3 times a minus 3x, that'll become a plus 9x because I had a negative times a negative, right? Then minus 3 times a plus 5, that'll become a minus 15. And so I don't have a column for that one, so I start a new one. And then what we do is we just kind of combine our like terms vertically. So I only have I only have a single term for x cubed. It's 2x cubed, so I'll go ahead and bring that down. So 2x cubed, okay? Then let's see, I have a minus 6x squared and a minus 3x squared. They're on the same team, so we'll combine that together to be a minus 9x squared. Then I have a plus 10x and a plus 9x. They're on the same team. Add that together, that'll be plus 19x, and then I'll bring down the minus 15. Okay, on this next one, it's pretty identical to the last problem. So we'll start by multiplying all of them by 2x. So let's see, we'll get 2x to the third power minus 8x squared and then plus 6x. And then now we'll multiply the minus 1 by all these, which is pretty easy. It just changes all their signs. So I'm going to have a negative x squared, a plus 4x, and then a minus 3. Give myself a little bit of space. Okay, and then, so right here, there's an understood 1 in front right there. So let's see, I have 2x to the third power. Then I have minus 8x squared minus 1x squared. So that'll combine together to be minus 9x squared. Plus 6x plus 4x, that'll be plus 10x. And then bring down the minus 3. And there we are. Okay, all right. Same, but